Hello everyone, this presentation will be about 12D model surveying fundamentals. This will be jointly presented by myself, Adam Eagle, and Ben Murphy of EXDS. Ben and myself are both surveyors. We have extensive experience in the use of 12D model and years of surveying experience on the tools. This presentation describes the workflow to take raw survey data from the instruments, reduce it in 12D model, and enhance data with the use of map file. You'll also be shown how errors in your field work can be easily corrected within 12D model. In this talk, we're going to cover how to convert the raw survey data into 12D friendly format. We will discuss some of the more commonly used reduction methods. We will show you the best practice methods to edit the survey, and also a few of the exporting and reporting options available within 12D model. So firstly, you need to get your survey data off the instrument and into 12D model. Unfortunately, however, each brand of data collector has its own method of communicating with a computer and a software package. To allow for a variety of data collectors, 12D model provides you with preset data collector definitions. Some of the more common types are Trimble, Leica, and Sakia. Within each definition, you can also select the appropriate surveyed style from the list, such as string before feature or string after feature, to allow for different surveying methodologies. To read your data into 12D model, you first need to convert the raw data into a field file. As you'll see in a moment, this is a simple method using a tool to select the raw data, then press convert, which will then do the work for you. The raw data file is converted to a standard 12D model raw field file format, known with the extension .fld. Now over to Ben to show you how it's done.
Thanks, Adam. The file that I want to convert for reduction today is in my working folder. It is a .sdr file and it has come from a Sakia instrument. If we take a look at this file, we can see that the code names come before the string number. That's important to know when setting the data collector, as we need to specify that. To set the data collector, I'm going to come to Survey, down to Setup, then I'm going to use the drop-down arrow to pick the appropriate data collector. Because the feature code is coming before the string number and it's coming from a Sakia instrument, I'm going to choose the Sakia feature string option. Once I've chosen this data collector, I can hit set, and it says the active data collector has been updated. I can then hit finish. Now that we've set the data collector, it's time to convert the SDR file to a .fld file. To do so, we're going to come back up to the survey menu, down to convert raw, and we're going to hit the little yellow folder button, which is going to show us that our SDR file is here, which is sitting in my working folder. I can double click on that, and that will automatically populate the file name for the field file. Once that's set, we can go ahead and hit convert, and it says the file will be created. We can then hit finish, and if we come back to our working folder, we can now see that there is a .fld file ready for us to reduce.
Okay, now that you brought your data into 12D model, the next step is for the 12D field file to be read into a survey reduction function and reduced. In most lines of the field file, a feature code, string number, point name, and point text are given and are stored next to each other, separated by tabs. Basically, the survey function keeps track of the 12D survey file data, the information involved in the survey reduction, and all the strings and models created by the survey function. The data for the survey function can also be edited and the reduction rerun, and all the old reduced strings automatically deleted and replaced by the updated reduced strings. If errors occur, the field data for this function can be interactively and or graphically edited. The reduction panel is made up of multiple options and it produces 12D model superstrings in one or many models, which Ben will now take you through.
Thanks, Adam. Now that we've created our field file, it's time to reduce it. To do that, we're going to come to the survey menu. We're going to come down to create, and we're going to choose the field file option. This is going to open up the survey data reduction function panel, or better known as SDR function. And the first thing we need to do is give it a function name. Now, I'm going to give it the same function name as my file name. I'm going to go ahead, copy this name, paste it into the function name, and then I'm also going to give it the same name for the default model. We're going to create a report file. I suggest that we keep the same naming convention, so I'm going to copy it into the report file name. What do I want to report on? Well, I want to report on everything. I'm now going to move the panel over to the left-hand side, and all that's left to do is come down and hit reduce. It'll say that the file has been reduced down the bottom, and then we can come and turn our model on, our 4339 ACO model, and there you have it. Our data has been reduced and displayed on the screen successfully.
So now you're at the stage where you can see your data on the screen. The next step is to visualize and sort out your data into separate models for a better representation. We do this with the use of a map file. In essence, it takes codes that you have measured in the field and places them into the correct models with the associated color, symbol style, or line type. The map file consists of sections of tables or grids, which are used to select specific data to set many string properties such as string name, colors, line styles, symbols, models, extrusions, and tintability for the strings that are being created. You'll now see your survey data can be best represented in 12D model using that map file.
Thanks, Adam. Before I apply the map file, I'm just going to come up and turn my point IDs off so we can see the data a little clearer. To apply the map file, we come across to the map file tab, select the map file we wish to apply. In this case, it's the road surveys map file, and I'm going to give it a prefix. The prefix I'm going to give it is Tech Forum 2021 and a couple of spaces. Do I want to use point line mapping? Yes, I do. All that's left to do now is hit the reduce button, and we'll see the data disappear from the screen. The reason that's happened is because the data no longer exists in the default model. It exists in the model specified from the map file. If we come up to the plus button and turn these models on, we can now see our data has been reduced with specific line styles and colors and in its appropriate map file models.
So, now that you've seen how your data is able to be portrayed, it is now time to show you some of the options within the reduction function. This function consists of many different tabs. One of those tabs is called the Others tab, which allows you to check on or off multiple options. One option is the Explode Point String option. This would ensure that all your natural surface levels are not joined together. So when you do a string inquire on one, they all don't highlight. If you have measured check shots, you can also tick this box to show these on the screen as points. Another option is to check on the reprompt all and tick on the backsite prompt mode. This will then run through and check the stations and backsite residuals, which will allow you to ensure they are within your specifications and tolerances. Ben will now take you through these options.
That's right, Adam. We can ask the SDR function to prompt us to check our backsite residuals as we reduce the data. We can also ask it to check our check measurements residuals as we reduce the data. Unfortunately, the data set that we have in front of us doesn't have any check shots in it. But before we go ahead and do that, let's take a good look at the report. If I right click on this yellow folder here and choose how I want to open up the report, I want to open it with Notepad. We can come down and have a look at our report, and we can see here that we've occupied station 1, and we've backsited to station 3, and here's all the survey data picked up from station 1. If we scroll further down, we'll see that we've occupied station 2 and backsited to station 1, and so on. Now, if we come across to the Others tab, we can choose a few options here to ask it to prompt us as we reduce the data. So I want to go ahead and tick Reprompt All. Do I want to show check measurements? Well, there aren't any check measurements, so I'm going to leave this one unticked. Here it says Assume Yes, and that's the default selection. We don't want to assume yes to the swings. We want to check our residuals as we go. So we're going to hit the drop down arrow and we're going to choose Prompt. All that's left to do is to hit the Reduce button. When we hit the Reduce button, a panel will pop up and say that we've occupied station 1 and we've backsited to station 3. We can see here the observed easting, northing, height and bearing and distance and the calculated, and we can see our residuals. We have a few options at the bottom of the panel. We can choose to accept this swing and move on. We can choose not to accept the swing, and we can choose to edit the station. Yes to all means to accept all swings on all stations, and no to all is to not accept the swings in the stations. I'm happy with these residuals, so I'm going to go ahead and hit yes. And straight away, we can see the data that's been surveyed from station 1 has now popped up on the screen. Another panel has now opened up and said that we've occupied station 2 and we've backsited to station 1. We can also see the radiation line graphically on the screen. Here's station 2 with our radiation line back to station 1. Am I happy with these residuals? Yes. Now the data that's been picked up from station 2 has also been added to the screen. Another panel's popped up and said that we've occupied station 3 and we're backsiding to station 1. Once again, I can check my residuals, and if I'm happy with them, I can go ahead and accept the swing. And just like that, we've re-reduced our data, but at the same time, we've checked our backside residuals as the reduction process has happened.
So you've now confirmed that your survey data is correct. The next step is to swing your data onto the correct azimuth. 12D model gives you the ability to do so. You do this by bringing in a control data via various methods and creating a model of these points. Under the Advanced tab, the name of the model can then be selected, and those points containing instrument and backside stations can be referenced during the reduction. The name of the string is taken as the station name, and if the string contains more than one point, the first point of the string is used for the coordinates of the station. Ben will now show you how this works.
That's right, Adam. It is possible to swing our data on its appropriate azimuth during the reduction function. All that needs to happen is we need to specify the control model on which we wish to swing our data to, and the control model point IDs need to match the station point IDs. So if I come up and turn my point IDs on, we can have a look at our survey data, and we can see that station 1's point ID is 1, station 3's point ID is 3, and station 2's point ID is 2. Now if I go and turn this view to the left here, and we have a look at our design view, I have the MGA control model here. I can come and turn our text on, and we can see that we have some string names or point names for these marks. Some of them are SSMs and some of them look to be nails or PPMs. If we come and toggle our point IDs on, we can see that we have some point IDs, and we have a point ID of 1 and a point ID of 2 and a point ID of 3. So hopefully when we swing this data in the next reduction, it's going to match up with these point IDs. Our stations will match with these point IDs, and the data will get swung to its correct azimuth. Before I do that, I'm just going to turn the backside prompt mode back to assume yes, as we've already checked our backsites and I don't want to be prompted again. And then we're going to come across to the Advanced tab. All we need to do in the Advanced tab is specify our MGA control model, then go ahead and hit reduce. The data has disappeared from the survey screen as it has now been swung from the coordinates that it was on assumed to its appropriate coordinates. So all that's left to do is to turn our data on the design view, and I'll go ahead and turn the text off, and we can now see that our data has been swung to the appropriate MGA coordinates. And down the bottom here, just below my mouse, we can see the X and Y are in MGA.
After bringing your data in, you may have some edits you need to do. Many errors in a raw data file are only detected after the reduction has taken place. They could be a coding issue, an incorrect height on your target or instrument, or any other number of mistakes you've either identified in the field or on the screen that now need to be rectified. These errors can be fixed by using the Edit Survey function. Any changes you make are then corrected, and the function is then recalculated to re-reduce the data. Selection for some edits can be done graphically, for example incorrect target height, and others through interactive editing of the survey field data. In all cases, once the edit is completed, the effect is immediately calculated and then displayed. So now over to Ben to show you what you can do.
As Adam stated, there are a few errors in the data here, so we're going to go through and do a few survey edits. I'm going to close down my survey data reduction function. There's no need to worry, we don't lose anything. We can open that reduction anytime we want and rerun it. I'm going to come and open up a new view, view 1, maximize this view, and I'm going to turn our data on. So as we can see, there are a few mistakes that have been made in the field, a few stringing mistakes. We can easily fix them using the survey edit tools, so let's go ahead and do that. First, we're going to come up to the survey menu. We're going to come down to edit, and then we've got all these editing function tools here. So we can do coding edits, we can do ordering edits, we can do edits by points, we can do stringing edits, and we can do target height edits. So let's go ahead and do a target height edit, because that's probably a common edit that's going to need to be made. So if we go ahead and hit change, and I'll zoom into a point somewhere, let's say this natural surface height, I can pick this point. And what it does is it'll show me what station it was picked up from. We can see the radiation lines coming from station 1, and it'll tell us what target height that shot was taken at. This shot was taken at 1.5. Let's say that that was incorrect and it needed to be taken at 2.0. We could change that target height to 2.0 and we could hit set. We've now seen the RL has been updated and that height is now correct. So I'm going to go ahead and finish that. Another few errors that we can see, it looks like there's been some miscorrected codes. So we can have a look here, we've got a lip 2 and this string here is lip 1. So I'd say that this point here probably needs to be lip 1. Just going to turn my vertices on to make it a little bit easier to see. And we're going to come up to the survey menu. We're going to come down to edit. We're going to come to coding and we're going to go to change. This allows me to pick the code that I want to change. Once again, it shows me where this shot was taken from. The radiation line is coming from station 1. And this code is not meant to be lip string number 2, it's meant to be lip string number 1. So all I need to do is change this 2 to a 1 and hit set. We can see now that the function is rerun and the correct code has been put in place. If for some reason I wanted to go back to the code that it was, I could go ahead and hit the reset button and this will take it back to the way it was. But I don't want to do that, I want to keep it at string number 1. So let's go ahead and change that again and hit set. And now that looks correct. There are a few more errors down here. We can see that this CG1 is coming from over here, this change of grade, when it probably needs to be CG2. So once again, I could go ahead and pick that point and I could change it to 2, or I could use the same as button, hit same as, pick the string that I need it to be, and it populates the fields with the correct information. All I now need to do is hit set, and we can see that change of grade has been updated, and over here it's been changed to change of grade 1. Another nifty little trick that we can do with the survey edits is we can see down here that we seem to have a bit of a bottom of bank string. Now it's bottom of bank string 6 and it looks like it's been picked up in the wrong order. It looks like this point here needs to join to that point and then the string should finish there. Now we could go and reorder the point IDs or pickup numbers if we wanted to, or we can come to our survey menu, we can come down to edit, we can come down to order and we can choose auto order. If I hit pick, come and pick this string and accept, we can see that 12D has already calculated the maths and reordered this string in its appropriate order. Go ahead and hit finish. I'm not going to touch on all the edits that's possible inside 12D because there are a lot of them, but they're some of the most common ones that you'll use. Yeah, go ahead and have a look inside here. There's some really, really cool things you can do.
Another way to make edits to your data is via the Survey Field Data Editor. All the commands in the field data can be modified or deleted, or new commands can be added. When changes are made, the field data is automatically re-reduced, so the effects can be immediately checked. You can insert, change, or modify any line in your field data, and when doing so, the lines will change colors to indicate what data you have made modifications to and what specific change you made. To make modifications, you simply need to select the line you wish to change, and all variables will become active. Ben will now take you through this editing option.
That's right, Adam. We don't have to use the survey edit tools under the survey menu. If you prefer to edit things through the file, that you can. The way we do that is we come under survey, under edit, and choose field data. This will ask us to pick a function name. We're going to pick our function and we're going to head and hit edit. This will open the survey field data editor. We're going to maximize that out a bit so we can read it clearly. And I'm going to put my data over here on the right hand side. Make this a little bit bigger. Now the great thing about this is whatever we do in this file updates graphically and vice versa. So if I go ahead and pick a string or a code or a shot, it's going to update the graphics on the right hand side and show me where that shot is and the radiation line from the station. This allows me to cycle through the lines in the file and I can see the radiation lines spraying out across the screen on the graphics. Now as we go down, we can see that we've got a magenta colored line here. If I click on that line, that's going to take me to the point that I edited previously. So that's another great feature of this editor, is if any edits are made, it recolors the line so they're easy to find in the file. There I can see where I changed the target height and so on. One of the other great features of this editor is I don't have to try and find a code by scrolling through the lines and waiting till I get to the point that I want to look at. I can come up and I can hit this little pink arrow here, which will allow me to pick a point graphically and take me to the line in the file. So if I hit this point and we come over and we click on a point on our screen and accept, you can see that it's automatically taken me to that line in the file. So if we wanted to come over and say, have a look at this stormwater pit, for example, and close it, I could come over here and I could use my find by pick, and I could pick the point. And now we can see that there's our 4 codes for the stormwater pit. Now we're going to want to close this. The best way to do that is to enter an opcode. To enter an opcode, we're going to come to the shot just after the code that we want to put the opcode in. We're going to come up and we're going to hit insert. This is going to bring up the new field data command, and it will give us an option of list of possible opcodes. Now the opcode that I'm looking for is called string close, and that is opcode 20. I can hit select there and hit create, and then just hit apply. And that has now added this opcode called close string, and we can see that our string has now been closed graphically. Another thing that we can do inside the editor is if we come and pick another point, let's say we wanted to remove this point, I can delete the line in the editor, and that point has now disappeared graphically, and we can see here that we have a red X next to the point that's been deleted. To bring that point back, all I would need to do is hit the delete button again, and it reruns the function, and that point has now come back. So it's pretty easy to do edits either from the survey editing tools or with the field file. Either way, the graphics will update or the file update. They talk to each other, and that's the beauty of SDR.
Another way to make changes to your survey data is to do CAD edits. However, we recommend that you first do all of your edits to your survey data using the previous editing options. After you've made all the required edits to your raw data, we recommend that you lock your survey reduction and then make use of the CAD edits. The CAD Edits menu has a multitude of options available to you to use, such as close, open, join and clip, just to name a few. Now over to Ben to show you how to lock your data and how to use the CAD Edits.
So as Adam just explained, and as I said earlier, it is best practice to do all your survey edits inside the survey editor or using the survey edit tools. It's not to say that you can't do CAD edits, but when doing CAD edits, if you don't lock the function, the next time the function is rerun, you will lose those CAD edits. To demonstrate this, I'm going to go ahead and close the editor. I'm going to maximize this view here. I'm going to go have a look at another stormwater pit. Now, if I come over and I use CAD close and pick that pit and close it, we can see that the pit has been closed. But then when I come and rerun my function, if I come under edit and go to function, pick the function, go ahead and hit reduce, we'll see that we lose that CAD edit. That's because CAD edits are not written to the file. So every time this function is re-reduced, the file gets reread and everything gets deleted and repopulated. We can see that the close that we did before inside the file is still existent because it's been done inside the file. So if you get the CAD edits and you want to keep them, how do you do it? Well, what we need to do is we need to lock this function so no one can rerun it again. And to do so, we come up to Utilities, under Functions, under Lock, choose the function that we wish to lock, and tick Lock. Once we hit Set, that function is now locked. I can now come back, choose CAD Close, close that string, and then if someone comes to rerun the function, or I try to rerun the function, we pick our function, and I hit Reduce, I'll get a red warning up here, and down below it says the function is locked and cannot do recalcs.
12D can produce a range of reports that will allow you to demonstrate quality assurance to your clients. The Survey Reduction Report is one of these reports, and it will provide you with a text document outlining the measurement information, station information, and any changes made. Ben will now show you how these reports are created.
Thanks, Adam. To produce a report, we come down to Report, pick the function that we want to report on, give it a file name. I'm going to go Control Copy, and we're going to paste that file name, but then I'm going to put the words final after it, and I'm going to go ahead and hit Report. This automatically opens up the report in Notepad, and if we scroll down through the report, we'll be able to see there's a little C next to the lines, and these C means that there's been a change made to the field file. So you can use this report for QA purposes. I could send it to my boss. My boss could have a look at the report and see that I've made a few survey edits. He could give it the final tick of approval before going to the client. And it's that easy. Well, that's it for me today, guys. Hopefully you have learned some beneficial stuff about 12D model survey fundamentals and how we reduce a raw file and bring it into 12D and some of the reduction methods inside SDR. My name's Ben Murphy, and I'll see you next time. Back to you, Adam.
Ben and I would like to thank you for listening to today's presentation. We hope you're able to get something out of it. For any future inquiries, please contact 12D. Thank you.